Hi everybody. Today we're going to learn about one of the most inefficient sorting algorithms out there, and that is Bogosort. And to help explain how Bogosort works or doesn't work, I'm going to give you a live demonstration. So what I have here are I have 5 colored ping pong balls, and they're all numbered sequentially from 1 through 5. For example, the one ball is this blue one right here, and then we can see that the number 2 ball is somewhere here. Is it the purple one? Nope. Well, the yellow one is number 2. You can kind of see it's not very efficient the way I'm doing this. So you have number 2 here, and then you have 3, and it goes all the way to the very last value, which is going to be 5. And so the way Bogosort works is that you have some unsorted values and you want to sort them. And it does so not in a way where we start by having some kind of logic behind how we sort. No, it works in a manner very similar to this. I have a box. I'm putting all of the balls inside the box. I'm going to shake this box. I'm just going to randomly pick an item out from it. Okay, first one happens to be 1, which is what I want. Second value happens to be 4, not what we want. So right now, our sorting has already fallen apart. What am I going to do? If I had to put on the mental state of Bogosort, I put all the items back, put them back in this box, shake all the items again, shuffle them, and then count all the values from the beginning again. Okay, starting with 4, 3, all right, already back to the right spot. So this process repeats itself for a very long period of time. I keep checking if the values are sorted. If they're not, I put them back, I shuffle them all again, and pick the items out and check again. One could imagine, hopefully, with only 5 items in this box, that maybe in the next 10, 15, 20 minutes, I'm able to eventually get to the point where the ordering is sequential and I'm able to pick the items out easily. But because it is all random, I could also be doing this for days, which is not exactly what we want. And so Bogosort does not work in any smart, intelligent way. It literally works by randomly hoping that you get the right value at some point in the near future. So let's dive a little deeper into how Bogosort works. So let's start with a different set of numbers we want to sort. Here we have 5 values again. The numbers are 5, 0, 30, 9, and 3. And we want to sort them using Bogosort. Now, the way Bogosort would sort these numbers, as you may have gathered from the demonstration earlier, is there are 3 steps. In the first step, we shuffle the input array or list of items and shuffle them to make them random because we don't want whatever order is currently there. Next, we check if the shuffled array or the shuffled set of values are not magically in a sorted order. And number 3, and this is the part that often takes the most time, is we repeat. If the list is not sorted, go back to step 1 and repeat the process again. This is the equivalent of me taking all the balls, putting them in the box, shaking the box, checking if the order of the balls in the box are sequentially ordered from 1 through 5. They're not, putting them back, shuffling them again, this over and over again. This is the bulk of the logic. In fact, it's the entirety of the logic of how Bogosort works. And at each step, the important detail to note is that there's no logical or deterministic way to figure out what the array will look like. It is entirely based in a very random fashion. So typically when we look at a sorting algorithm, we go from step 1, step 2, step 3, and ultimately converge upon the final solution. With Bogosort, there's no such thing. Each step is just as random and unrelated as a step before it. So here you can see our iteration 0 is our starting point, which is our values are 5, 0, 30, 9, and 3. It is shuffled randomly. So iteration 1 has the numbers arranged in 9, 5, 3, 0, and 30. Great, doesn't matter. Iteration 2, we take those values, just shuffle them again. There's no checking to see if any values in the correct position. Maybe let's not shuffle those values that are in their correct position, only shuffle the values that are not in their correct position. No, that would be adding logic to the sorting process that is beyond just shuffling randomly. And the hope is that eventually, after a very long time, you'll get to the very bottom, iteration n, an unknown amount of steps later, the values would have been sorted just like how a broken clock is right twice a day. Our values will have randomly found themselves in the correct order at some point in time. And so Bogosort is not a very efficient sorting algorithm. In fact, it should never be used in any real world setting. Its primary purpose is to kind of used in academic situations, or like what we're doing right now, to kind of explain there are many ways to sort something, and some of the worst ways to sort can be done by just randomly shuffling, which is viable. It is an algorithm. It is a approach to sort the values. It's not a very efficient one. Definitely far worse than any of the approaches we might have looked at so far. And so if we had to look at what is the timing for this, well, there are three ways of looking at this, which is very distinct for this one compared to other algorithms. The best case is that the very first time Bogosort sorts your input values, everything's already sorted. That is the best case scenario. Fantastic. You lucked out. You don't have to worry about anything. The average case is going to be the factorial, big O of n factorial, where the number of inputs, the factorial of those inputs is the amount of time it's going to take. And that's the average amount of time it'll take based on how often it takes to arrange a set of items, in a collection. Now, the worst case scenario is it's infinite, because you're just shuffling randomly with no logic, with no path to converge onto a solution. You could potentially be sorting forever. And therefore, the worst case scenario is that Bogosort never ends up sorting the values you might have. And this gets worse the more and more numbers that you have. So for 5 values, you can see that eventually I'll get to the solution quickly. To get more details into Bogosort and how to actually implement it, like there's JavaScript code and a running example that I provide here, just go to my article on Krupa.com for Bogosort. Easiest way to find it is go to Google, type in Bogosort Krupa, and you'll see that as the first value there. There you'll see the JavaScript version and then a little bit more details on how to implement Bogosort should you want to torture your application with a really bad way of sorting something. If you'd like to go deeper into data structures and algorithms, learning not just about Bogosort, but the more efficient versions of sorting algorithms that exist out there, check out my best-selling book on this topic, Algorithms, Absolute Beginner's Guide, available in paperback and Kindle and other digital formats in physical bookstores as well as virtual bookstores. So definitely do check it out. And if you like this video or you didn't like this video, that's okay. Tell your friends and enemies all about it. Like, comment, and subscribe. Sign up for the newsletter to have your inbox filled with random tips from my learnings and discoveries along the way. Follow me at Krupa for bite-sized updates on Twitter and other social media networks where at Krupa is going to be referring to me. And lastly, I write books on other topics beyond just data structures and algorithms. So check them all out if you are so interested. And with that, I will see you all next time.